So on router number 1, you can see I am running this subnet 100.1.1.0/30 between ISP and router number 1, and we have some loopbacks 1.1.1, 1.1.2.1, 1.1.3.1, 1.1.4.1, 1.1.5.1, right? Between router 1 and router 3, I am using this subnet 13.1.1.1. And here I think in task we have instruction to use IP addressing also from this subnet 123. This is router ID na? Here configure IP addressing on router as shown in the diagram. 123.45.67.x is the major network. From this network you need to subnet, right? And between routers, like we need two IP addresses, so here you can see the IP configuration. Between router 1 and router 2, I am using 67.0, means 123.45.67.0. Between router 1 and router 4, I am using 67.4. Between router 3 and router 2, I am using 67.8. Between router 3, 4 and 5, I am using 67.16/29 here, because here we need three IP addresses. So you can use this, IP addressing. But here in my topology, I am using different subnets, no problem. We can perform same lab with different IP addresses also. Now on router number 2, so IP protocol, EIGRP is not running, but IP is already configured. So IP interface brief exclude unassign. So here also you can see IP configuration is done on router number 3. Let me lock the lab. Router 3. So IP interface brief exclude unassign. So here we don't have any loopback. We have IP addresses on physical interface. That is fine. On router number 4, enable. So IP interface brief exclude unassign. So IP interface brief. Okay. So here also we have IP addresses on physical interface, and on router number 5, I am expecting some loopback. So IP interface brief exclude unassign. So yes, here we have some loopback 5.1.1, 5.1.2.1, 5.1.3.1, 5.1.4.1, 5.1.5.1. Now first task is here, you can see configure EIGRP. First task is configuring IP addresses, so IP configuration is already there. So configure EIGRP on all routers. The autonomous system number should be 123, and every router should have router ID 123.x.x.x/32. Okay, so let me configure it first. On router number 1, we'll start from router number 1. On router number 1, config T, router EIGRP ES number 123, and then a router ID. I think what is the command to configure EIGRP router ID? EIGRP router ID 123.1.1.1. Fine. Then network 13.1.1. I'm running 13, right? 13.1.1. 13.1.1.1 0.0.0. After that, network 1.1.0 wildcard mask 0.0.255, network 1.1.2.0, 1.1.3.0, 1.1.4.0, 1.1.5.0, 5.0. Done. This is the EIGRP configuration on router number 1. Let me take you to R2. On R2, okay, fine. On router number 2, router EIGRP AS number 123 and EIGRP router ID 123.2.2.2.2. Fine. Then network 24.1.1.2 0.0.0. Here let me check the IP again. 24.1.1.2. perfect. Okay, and then which network? Network 23.1.1.2 0.0.0 and network 2.1.1.0 0.0.255, network 2.1.2.0, network 2.1.3.0, network 2.1.4.0 and network 4.0, let's say 5.0 and 4.0. Done. Now let me take you to R3.
Prabhu, sorry for the interrupt. I think a 14th network is not advertised in R1.
Yes, yes, exactly. Right here we need to run one more network command 14.1.1.1 0.0.0. Okay. Yes.
Right.
Then on router number 3, router EIGRP AS number 123. If I will configure EIGRP AS number, different AS number here on router number 3, let's say 10. Will EIGRP neighborship come up between router 1 and router 3? If I will configure different EIGRP AS number?
No, it will not.
This is AS number is EIGRP neighborship parameter, right? AS number must be match. Okay, router EIGRP router ID 123.3.3.3. Then network 13.1.1.3 0.0.0. Then network see EIGRP neighborship between router 1 and router 3. Then which network 23.1.1.3 0.0.0. And then which network 10.1.1. I have to check IP on this interface. Fast Ethernet 0/0 10.3. So 10.3 0.0.0. Here we don't have any loopback, so we have enabled EIGRP on these three physical interfaces. Finally, let me configure EIGRP on router number 4 now. R4, here it is, and config T router EIGRP S number 123, EIGRP router ID 123.4.4.123.4.4.4 and then network 10.1.1. IP address on this router is 10.1. On fast Ethernet 0/0 10.4. So 4 0.0.0. Then which network 24.1.1.4 0.0.0 and network 14.1.1.4 0.0.0. Fine. So here you can see so IP EIGRP neighbor. So 14.1.1.1 means router number 1, 24.1.1.2 means router number 2, and 10.1.1.3 means router number 3. Fine. Now let me configure EIGRP on router number 5.
Here it won't show the neighborship as the EIGRP router ID. Yeah?
No, IP address of neighbor. It is showing IP address of neighbor.
Okay.
Here router EIGRP AS number 123, EIGRP router ID, EIGRP router ID is 123.5.5.5 and network 10.1.1.5 0.0.0 and then network 5.1.1.0 0.0.255 and 10.5.1.2.0 5.1.3.0 5.1.4.0 and 5.1.5.0. Fine. So we have configured EIGRP on all routers. Now we are going to verify. See, task number 1 is done. Task 1 is done. Now in task 3, configure the router such that they should send hello message after 3 seconds and hold on. Neighbor should hold that information for 9 seconds. So we need to change hello time, hold on time, and hop maximum, hop count. EIGRP uses hop count not to calculate metric, but it is still using, right? This is property of distance vector routing protocol. That as I told you, EIGRP is an hybrid routing protocol. Means it is using some properties of distance vector and some properties of link state routing protocol. So hop count, here we can configure the hop count, means how many hop, till how many hop networks are reachable. So here actually concern is, see, for the security purpose in this topology, any router will receive any prefixes, like router number 2 is receiving prefixes which is running on router number 1. So either it can receive from router number 4 or either it can receive from router number 3. So this network is how many hop away from both neighbor? 1 hop, 2 hop, 2 hop. So if you will configure 3 hop, that means this prefixes is reachable. If any prefixes router will receive from more than 3 hop, means prefixes away from 3 hop are unreachable. Prefixes coming from 3 hop away are unreachable, right? So we need to configure these 3 things: hello time, hold on time, and maximum hop count, right, on all routers. Let's start from router number 1. And on router number 1, if you will verify routing table, so IP route EIGRP, so you can see it is receiving all 2 prefixes and it is performing load balancing, and it is receiving all 5 prefixes and it is performing load balancing. From both sides it is calculating equal cost. Now on router number 1, I am going to configure hello time and hold on time. In EIGRP, if you want to change hello time and hold on time, you will change it on the interface mode, right? On the interface you can change it. So interface range fast Ethernet 0/0 and fast Ethernet 2/0. I am going to change hello time and hold on time on these 2 interface. Here I will run command IP hello interval for EIGRP S number 1 to 3, and what hello time we need to configure here, 3 seconds. So let me configure 3 seconds here. Will EIGRP neighborship goes down here when I will change hello time on router number 1?
No, I guess.
Will hello time impact EIGRP neighborship, guys?
I think will not.
You think?
I guess no.
You guess no.
Because it is already established, right?
Doesn't matter it is established or not. Tell me EIGRP neighborship parameter. ES number must match, K values must match. I never tell you that
Yeah, it will impact.
no, it will not impact.
Because neighbor all the time is K value will be changed, right? When we are changing in the R1, neighbor K value will be different, right?
Yeah, on router number 3 and on router number 4, K value is
will
5
be
seconds.
different.
But
Then
EIGRP neighborship, hello time and hold on time not matter. This is not EIGRP neighborship parameter.
Got it, bro.
Okay, and
Right,
here we
only
need
delay and bandwidth, right?
delay bandwidth autonomous system.
Yeah, right,
And subnet.
got it.
Subnet should be same, autonomous system number should be same, and K values should be same. EIGRP neighborship will come up. If you have configured authentication, so authentication should also be same. This is EIGRP neighborship parameter. In OSPF, you will see hello time is also OSPF neighborship parameter. So if hello timer is different on 2 routers, in OSPF neighborship will not come up. But in EIGRP, it doesn't matter, right? So here we need to change hold on time also. So IP hold on time for EIGRP 123 and hold on time should be what? 9 seconds. Hold on time should be 9 seconds. So here I can configure 9 seconds. Doctor number 1. 9 seconds. Done. How to verify EIGRP hello time and hold on time? What hello time is configured on this router? Can anyone tell me how I can check it? What hello time is configured on this router?
Show IP protocol.
Okay, first of all, tell me how to configure maximum hop count.
Metric maximum hop.
And you can see the range. Okay, so here we need to set 3. Fine. And in show IP protocol, show IP protocol, where is hello timer? Maximum hop count is now 3. You know variance. What is variance? Variance value is, you can see by default 1, but here we are not able to see hello time.
Under EIGRP neighborship.
So IP EIGRP neighbor. No. So here we can find it by checking the value hold on time after what second this value is resetting. So we can find, but what is the exact command? I also don't know. That's why I'm asking. So IP EIGRP topology. Inside the topology table also we are not able to see hello timer. So IP EIGRP AS number 123 interface topology
There is something timer.
timer.
Probably we need to check in the interface, right? So
Show run. Show run.
So run.
Uh,
Definitely in the running configuration we can see the configured timer, but let's say I have not configured on router number 2. Okay, I want to see timer on router number 2. On router number 2, do you want to see running configuration here? So run.
Prabhul, show IP EIGRP interface details. That interface details.
So
Interface ID.
so
IP
EIGRP
EIGRP interface
interface
details.
T time.
Yeah, fast Ethernet. Yeah, interface ID and details.
Nothing is there.
No, details. Just no. After interface ID, put in details. It will detect or not?
No, there is no any option for T time.
Okay.
You can Google it also. Hello. Means you guys have not configured any lab of EIGRP. That's why you don't know.
I have done this lab already.
So you have never think about the timer, where how to check hello timer or these things. Interface, I think so here we can use detail command. Detail command is there. Yes. And then fast Ethernet 0/0. This command is also not showing. Is there any more command? There was one command. Now I am also not getting. So IP EIGRP interface detail. Yes, here it is. Hello interval is
Yeah, right.
5 second and hold on interval is 15 second, but we have changed it on router number 1 on fast Ethernet. This is on loopback 1 interface and loopback 0. On fast Ethernet 0/0 you can see hello timer. On fast Ethernet 0/0 or fast Ethernet 1/0 is not 1/0, 2/0. Here you can see hello timer is 5 second, hello interval is 5 second, and hold interval is 15 second. On fast Ethernet 0/0, fast Ethernet 0/0, here value should be on where is fast Ethernet 0/0 on this router. Here timer should be 3 second and 9 second. Maybe this is problem of simulation software, but it should, here timer should be show run section EIGRP. Here I think I have changed the timer. And hold on time 9 second, but still it's showing 5 second as a hello time and 15 second as a hold on time. Okay, for now let me configure hello time and hold on time on router number 2 and router number 3. So on router number 2, interface range F0/0, F1/0, 1/0 and F2/0. IP hello EIGRP 123 3 second, and IP hold on time EIGRP 123 is 9 second. Done. Then on router number 3, enable config T, interface range F1/0, F2/0 and F0/0. IP hello EIGRP ES number 123 is 3 second, and IP EIGRP IP hold time for EIGRP 123 is 9 second. And then router EIGRP 123 and metric maximum hop is 3 also, and on router number 2 also let me configure maximum hop 3. Router EIGRP 123 metric maximum hop 3, and finally on router number 4 and on router number 5. On router number 4 config T. Okay, it will take now some time. On router number 5, enable config T, interface fast Ethernet 0/0, IP hello interval for EIGRP case number 123 is 3 second, and IP hold on time for EIGRP 123 is 9 second. And then router EIGRP 123 and metric maximum hop maximum. This is maximum path. We have configured maximum path. This is not maximum hop. On all routers we have set maximum path, means it can install maximum, sorry, this is hop, that is fine. I was thinking that we have configured path here, maximum hop. There is one more option to configure maximum path also. Like here you can see I have one more command, maximum path. So we can configure maximum path also, like maximum path should be 2 or maximum path should be 3. So we can configure up to 32 maximum path, means router can install up to 32 paths in their routing table. It can perform load balancing for up to 32 paths. Fine. And then on last router, router number 4, I was thinking I have changed maximum path. So interface range F 0/0 F 0/0, where is router 4, 0/0 and F 2/0 IP hello interval for EIGRP 123 is 3 seconds, and IP hold on for EIGRP 123 is 9 seconds. Then router EIGRP 123 and metric maximum hop is 3. Fine. Now task 2 configuration is done. Let me check R1 again. R1 routing table. So IP route EIGRP. Yes, it is receiving all 2 prefixes and 5 prefixes from both neighbor. And Dhana, see, neighborship is not flapping, right? So maybe that was problem of GNS3. Okay.
Okay.
Now task number 3. Next task is, see, task 4 is, in the topology R1 and R2 should receive all the loopback route of router 5 via router number 3 and via router number 4 as a best path. On both router R1 and R2, you need to verify that all the loopback of router 5 is best path via both neighbor, via router number 3 also and via router number 4 also. Yes, we can see on router number 1. On router number 1, so IP route EIGRP. Let me maximize it. See, it is receiving all 5 prefixes from both neighbor, and it is calculating equal FD, equal matrix. So it is performing load balancing. One is from router number 4 and one is from router number 3. In the same way, router 2 should also receive all prefixes of router 5 from both neighbor with equal matrix. So let me show you here. So IP route EIGRP. So inside the EIGRP routing table, you can see this router is also performing load balancing. It is receiving all 5 prefixes from both neighbor router 4 and from router number 3 with equal FD value, means matrix, right? And it is performing load balancing. So to achieve this task, you don't need to do anything. If you have configured everything correctly, automatically you will see router 1 and router 2 is receiving all the loopback of router 5 via router number 3 and via router number 4. Correct. Now task number 5. R5 should receive all the loopback routes of router 1 and router 2 via router number 3 and router number 4 as a best path, as a best route. Yes, definitely on router number 5 we can check that router 5 is receiving all the loopback of router number 1 and router number 2 from both neighbor, from router number 3 also and from router number 4 also. Yes, let me check here. So IP route EIGRP. So you can see these are the loopback of router 1 and these are the loopback of router 2. So all the loopback of router 1, router 5 is receiving from both neighbor, from router 3 and from router number 4 with equal FD, means equal matrix, and it is performing load balancing. Same way it is performing load balancing for all the prefixes of router 2 also. So to achieve this task also, you don't need to configure anything. If you have configured everything correctly, router 5 will receive all the prefixes of router 1 and router 2 via both neighbor. Now to achieve task 6, what is saying now, ensure that router 1 and router 2 should receive each other routes and routes from router number 5 via router number 3 as a best route and via router number 5 as a backup route. to perform this task, you are allowed to alter only interface characteristic. So here you need to change interface bandwidth, or you can change interface delay. You can use interface characteristic, anything. So how to achieve it? Task is very simple. What it's saying, router 1 and router 2 should receive each other routes and router 5 loopbacks via router number 3 as a best and via router number 4 as a backup. It's like router number 1 will receive this prefix and this prefix. It is receiving these all prefixes from both neighbor, from router number 3 also, from router number 4 also. But now on router number 1, it should receive these all prefixes from router number 3 as a best and from router number 4 as a backup. Means this path should be in topology table only, and this path should be in topology table and routing table. This path should be in topology table and in routing table. How to achieve it? How to achieve it? How I can achieve this? Yeah.
We have to change the delay of all interfaces of R4. We have to change the
R4.
delay.
This interface, fast Ethernet 0/0.
All the interfaces.
All the interfaces.
I applied like that.
If I will change, see, first of all, router 4 is receiving these prefixes on which interface? On this interface, right? And okay, leave here. Router 1 is receiving all the prefixes from router number 4 on which interface? On this interface?
Yeah, and that interface alone, if you change it, will not take effect.
See, we have multiple options. Now we can change bandwidth or delay of this interface and this interface also, or I can change bandwidth and delay of this interface directly, because whenever router 1 will receive any prefixes from router number 4, it will calculate different metric, because this interface bandwidth is different, this interface bandwidth is different. It is receiving all the prefixes from router number 3 on this interface, and it is receiving all the prefixes from router number 4 on this interface. Yes. One minute. Just time for me. Yes. Any confusion? Actually, just you need to keep in mind one thing, that router is calculating FD value or metric on the basis of receiving interface characteristic. See, whenever router 1 will receive any update message from router number 4 on this interface, how router 1 will calculate metric? It will compare bandwidth which is coming in update and bandwidth of their own interface, right? It will select least bandwidth, and then it will check delay which is coming in update and delay of my interface. It will add both delay value and then it will calculate FD value, correct? So we need to change characteristic of receiving interface. Now if I will change the bandwidth of this interface, router 4 interface bandwidth. So router 4, when router 4 will advertise update message to router number 1, it will share this interface list bandwidth. Maybe bandwidth which is coming in update is what, 100 Mbps, and bandwidth of their interface is, let's say, 90 Mbps. So it will advertise what bandwidth? 90 Mbps, list bandwidth, correct? So this is also one way to manipulate the path. And another option is, okay, if router 2 is advertising what bandwidth? 100 Mbps bandwidth. Router 4 will also advertise 100 Mbps bandwidth. But here I will set bandwidth 90. So now what will happen? For these all prefixes and for these all prefixes via router number 4, router will calculate different metric value, right? And when router 3 will advertise again this network and this network, it will calculate different metric. Am I right? So either we can change the delay and bandwidth of router 4 interface But we don't need to change this interface bandwidth. When I need to change this interface bandwidth, when router 1 will advertise prefixes to router number 4. So this interface is this time receiving interface. When router 1 will send these network information with the help of update message to router number 4, that time this interface is receiving interface. That time we need to manipulate the interface characteristic of this interface. But for these two prefixes and these prefixes and these prefixes on router number 1, I want to use this path as a backup path. So I can change this interface bandwidth, or I can change this interface bandwidth or delay, right? Automatically metric will be changed for this network also via router number 4. Okay, now guys, second question is here. Let's say I am going to change the characteristic of this interface router 1. If I will, let's say, decrease the bandwidth, if I will decrease the bandwidth, will metric increase? Metric will increase or decrease if I will decrease the bandwidth? If I will decrease the bandwidth, metric will increase or decrease?
Increase.
Increase, right? Because bandwidth is inversely proportional to metric. So if metric over here will decrease from this path, is when it will compare, automatically it will install only this, router 1 will install only this path, best path. This path will become best path. So here I need to increase. Okay, if I will decrease the delay, if I will decrease the delay, then metric will increase or decrease?
Decrease.
Decrease, because delay is directly proportional to metric. Formula is what? 10 raised to power 7 upon least bandwidth plus total delay upon 10 whole multiply by 256. This is formula. So delay is directly proportional and bandwidth is inversely proportional, right? So either we can use bandwidth or delay. So to achieve this task, see, on router number 1, for now router 1 is receiving all prefixes from both neighbors. So IP route EIGRP, right? For prefixes of router number 2 and prefixes of router number 4, it is performing load balancing. Now I am going to change bandwidth or delay of receiving interface fast Ethernet 2/0. What value you want to set? Yes, Dana, what bandwidth I will set here, so that this path, means via router number 4, should be feasible successor, should be in the topology table. I am going to use this path as a backup path. So what should be the bandwidth here? What bandwidth you have configured in your lab?
Delay 50.
Delay 50 on router
Yes.
number 4, on router number 1.
I configured on router number 4.
Let me configure on router number 4. So on router number 4, interface fast Ethernet 1/0. Here you have configured what delay?
50.
15.
50. 50.
50. Done. Now let me check R1. So IP route EIGRP. Oh, I think I have set it on fast Ethernet 1/0. That is correct. Now so IP route EIGRP. See, router 1 is now not performing load balancing for all router 2 networks. Router 2 is advertising these all prefixes, and router 1 have installed these all prefixes in their routing table via router number 1. Why? Because see the topology table, so IP EIGRP topology. Inside the topology table, you can see for these prefixes, we have now only single path. Yes, Dana, we have now only single path. Where is feasible successor?
The routes will prefer
this is the best path.
Yes,
But-
R3 is the best path,
but,
right? 13.1.1.1.3.
right, but backup path is not there, na? If let's say R3 will goes down, router 1 will generate query message for router number 4. But if there will be one feasible successor here, then it will not generate query message. So task is very simple. Via router number 4, this path should be the backup path. Via router number 4, router 4 should be backup route. But in this scenario, router 4 is not backup route. It have removed the path via router number 4. So let me do one thing. Here I am going to say metric is delay is 9. Just I have decreased delay by 1. By default delay value is 10. So now let me check topology table again. So IP EIGRP topology, and this time you can see in the topology table we have two paths with different metric. Via router number 4, this is the metric. Via router number 3, this is the metric. And in the routing table, so IP route EIGRP, in the routing table you can see all two prefixes are reachable via router number 4 now.
It's preferring 4.
Right? It is preferring router via router number 4 because we have decreased the delay. So if we will decrease the delay, metric will decrease. So now router 1 is calculating list metric via router number 4. So what we need to do, we need to increase delay by at least, let me configure 11 here. And now if you will check topology table, so IP EIGRP topology, wait, no, there is, so IP route EIGRP. Now best path is via router number 3, and so IP EIGRP topology, in topology table we have two paths. Correct? This is the task. Now you can see via router number 4, this is backup path. Via router number 3, this is best path. Okay, we will do same thing for 5 prefixes also, like a prefix which is running on router number 5. So I need to configure delay value 11 on this interface because this interface is receiving interface, right? This interface is receiving interface. So here on router number 4, I am going to see, for now router 1 is performing load balancing for 5 prefixes, right? It is still performing load balancing for all 5 prefixes, but for all 2 prefixes it is not performing load balancing. There is only one best path and one backup path. How to verify backup path? We can check topology table. In topology table we have one feasible successor, right? We have 2 paths. So on router number 4 now, interface fast Ethernet 0/0. This is the receiving interface for 5 networks, right? The network which router 5 is advertising. Here I am going to say delay, let's say 11. And now on router number 1, you can see for 5 prefixes also best is via router number 3. And if you will check topology table, so IP EIGRP topology, inside the topology table you can see for 5 prefixes also we have 2 paths. But how many successors are there? Only one, right? This is backup path, this is backup path, this is best path. If best path will goes down, automatically backup path will become best path. Router will not generate any query message. Fine. In the same way, see on router number 1 we did the task. So IP EIGRP topology for all 5 networks, and for all 5 networks and 2 networks we have 2 paths in topology table, and in routing table for all 5 prefixes and 2 prefixes we have 1 path. So IP route EIGRP. Correct? Now we need to do same thing on router number 2 also. On router number 2 also, like router 1 is advertising these prefixes to router number 2 via 2 path. Router 2 is getting these prefixes and 5 prefixes also. Router 3 is also advertising and router 4 is also advertising. Again on router number 2 we need to install these prefixes and these prefixes via router number 3 as a best path and via router number 4 as a backup path. So again, what we can do here, here also we can change the delay value or the bandwidth value, or we can change this interface, because this is receiving interface for these prefixes and this is receiving interface for these prefixes. So we have again two options. Either I can change delay value of these two interface, or I can change delay value of this interface. Getting my point?
Same as changing all the interfaces of R4, changing the delay,
Yeah.
right?
Yeah.
Hmm.
Correct. Okay. So here simply we can do what? On router number 2, see, on router number 2, I think for 5 prefixes, here I have already set the delay value what? On fast Ethernet 0/0 11. So
Yep.
so IP route EIGRP 11. So that's why you can see for 5 prefixes it is not performing load balancing. But in topology table, so IP EIGRP topology, in topology table for 5 prefixes we have 2 path and 1 successor, right? So this path is feasible successor, where router number 4 it is backup path, and we need to change delay on fast Ethernet 2/0 of router number 4. So let me take you to R4 again and exit interface fast Ethernet 2/0, delay is 11. That's it. And now let me take you to again R2, and now if you will check topology table, see we have 2 path for 1.1 network also, like for the network which router 1 is advertising, 2 path, and in topology routing table, so IP route EIGRP we have only 1 path for all this prefix and this prefix. For these all prefixes, best path is via router number 3, backup path is via router number 4 on both router, on router number 1 also and on router number 2 also, right? So this is task number 6. Clear?
One question, Prabal.
Yes.
Actually, you told no, like if you are changing bandwidth or delay, it will affect the other services, right? If you are
But
changing
here in
the
the
bandwidth.
task it's saying, it's telling you to
Okay,
do it.
okay. In real time will not do this one, right?
Yeah, maybe let's say your scenario is unique and you need to change it. You can use it, right?
Okay. Then there is no way to
Perform path
get
manipulation.
backup path in the same, yeah, right?
Yes, brother,
There is
there
no
is,
way.
we discuss offset list also. Through offset list, we can do what? We can add some metric. Through that also we can achieve this task. But here in
Okay,
task, it's
but
saying to
here is
use
the task, right,
bandwidth
right.
and delay.
Okay, you got it,
This
got it.
task is just for learning purpose. Getting my point?
In real
Okay.
time, they use delay.
Hmm?
In real time, they use delay.
Delay, or we can use offset list also. Offset list, through offset list also we can add metric, na?
Can you do that?
Yeah, definitely. If I will remove this one configuration, in last video also I did that in last class. Like here, router 1 is receiving, let's say, these two prefixes from router number 4 and from router number 3. On this interface, if I will add some metric, let's say it is calculating metric 10 over here, metric 10 over here. Through offset list, what we did in last class, we add some metric. So here if I will add metric 5, so now router is calculating what metric here? 15, and what metric here? 10. Which path is best? This path is best. Automatically this path will become what? Backup path. Watch last video to configure offset list.
Yeah, maybe for one option you can show that once more if possible, sir.
Offset list.
Yeah.
Yeah, sure. First of all, let me finish this task, then I will remove this configuration of delay, and then definitely I will show you offset list configuration also. Okay. Now next task is R1 and R2 should receive each other routes, especially via router number 3, and they should receive one summary. Now this time it should receive one summary route from router number 4. See, again concept is same. This time what it's saying, router 1 and router 2 receive all prefixes like these prefixes and these prefixes via router number 3, right? And they should receive one summary route from router number 4 with /16. So how I will achieve this task? What I can do? I can advertise one summary address from router number 4. See, on router number 4, config t interface fast ethernet 2/0, I'm going to say IP summary address for EIGRP 123, and summary address is 5.1.0.0, then subnet mask 255.255.0.0. Correct? Now see on router number 1. So IP route EIGRP. So IP route EIGRP. It is receiving one summary route from router number 4 in the routing table, and it is receiving all individual prefixes from which neighbor? From router number 3. Getting my point? It is receiving one summary route from router number 4 and all individual prefixes from which router? From router number 3. Right? And router 2 should also receive one summary route from router number 4. So from router 4, from fast ethernet 1/0 of router 4, I will advertise one summary address, IP summary address for EIGRP S number 123, and summary address is 5.1.0.0 255.255.0.0. Done. You can check router 2 routing table now. So IP route EIGRP. Router 2 is also receiving one summary route from router number 4 and all individual prefixes from which neighbor? From router number 3. Getting my point? And from on router number 4, we can run one more command here, interface fast ethernet 2/0 IP summary address for EIGRP AS number 123 and 2.1.0.0 255.255.0.0. Now see routing table of router 1 routing table. So IP route EIGRP. Router 1 is receiving one summary route for this network for all 2 prefixes via router number 4, and it is receiving one summary route for all 5 prefixes from router number 4, and it is receiving all individual prefixes from router number 3. Done. Done, guys. Clear? Okay, so this task is also simple. We are now advertising all prefixes via router number 3, and we are advertising one summary route with /16 via router number 4. Now task number 7. R1 and R3 should receive R5 routes specifically via router number 4 this time, and they should receive summary route from router number 3 with /16. This time it is telling you to advertise summary route from router number 3 and all individual route from router number 4. So first of all, let me remove the configuration on router number 1. On this interface, I have run this command, and I have run one more command, route IP summary address for EIGRP S number 123 and which network? 5.1.0.0, 255.255.0.0, and then interface fast Ethernet 1/0, no IP summary EIGRP is number 123.5.1.0.0, 255.255.255. Sorry, 255.255.0.0. Now let me verify router 1 and router 2 should not receive summary route. Yes, now you can see it is still receiving one summary route. Wait. Interface fast Ethernet 2/0, fast Ethernet, no IP summary address for EIGRP 123.5.1.0.0, 255.255.0.0, router 1. Yes, now router 1 is not receiving any summary address from router number 4, and it is not receiving any summary address for 2 network also, and router 2 also, router 2 should also not receive any summary address now. So IP route EIGRP, yes, it is not receiving any summary address for 5 networks, and it is not receiving any summary address for 1 network. Now R3 should advertise one summary address to router number 1 and router number 2, and R4 should advertise all individual prefixes. So this time on router number 3 we can advertise summary address. So let me take you to R3. Interface fast Ethernet 1/0, IP summary address for EIGRP is number 123. Summary address for all the prefixes on router number 2 will be 2.1.0.0, 255.255.0.0 /60, and then IP summary address for EIGRP 123 is 5.1.0.0, 255.255.0.0. Done. After that, interface fast Ethernet 2/0, IP summary address for EIGRP 123 is 1.1.0.0, 255.255.0.0, and IP summary address for EIGRP 123 5.1.0.0, 255.255.0.0. Now we can check the routing table of R1 and R2. So IP route EIGRP. Now you can see it is receiving one summary address from which neighbor, from router number 3, and it have installed all individual prefixes from router number 4. It have received, installed, or all individual prefixes via router number 4. In the same way, for 5 prefixes also there is one summary route via router number 3, and there is all individual prefixes from router number 4. Now guys, can anyone tell me if 5.1.1. let's say this network 5.1.1.0/24 will goes down on router number 5, will R1 generate query message? No. Answer of this question is no, because there is one summary route available. Yes or no? Summary route is available. If this network will goes down, let's say 5.1.1.0/24, simply it will remove it from their routing table, from the topology table. And if router will receive any traffic where destination is, let's say 5.1.1.1, so it will use this route. It will use this route to forward traffic. It will forward traffic to router number 3. But if this network is available in the routing table, it will forward traffic to router number 4. Until and unless these all prefixes are available here, it will forward traffic to router number 4. Okay. Got it? Now next task is, see, before configuring next task, if you want to see offset list, how to achieve the same task with the help of offset list, how I can achieve it. On router number 4, I am going to set delay as a default on all interface range fast Ethernet 0/0, fast Ethernet 1/0, and fast Ethernet 2/0. No delay 11, right? Or we can say delay 10. Fine. Now see router 1 routing table. So IP route EIGRP. It is performing load balancing or not? It should perform load balancing. Just wait. It will perform load balancing now. So IP EIGRP topology. So IP route EIGRP. So actually it is receiving summary address now. Let me remove summary address also from router number 3. Interface fast Ethernet interface, we can use range command, not range, we cannot use range command here. Fast Ethernet 1/0. No IP summary EIGRP 123 5.1.0.0 255 255 0.0, and no IP summary no IP summary EIGRP 123 2.1.0.0 255.255.0.0. Then exit interface fast Ethernet 2/0. Say no IP summary EIGRP 123 1.1.0.0 255.255.255.0.0, and no IP summary for EIGRP 123 5.1.0.0 255.255.0.0. Done. Now let me show you the routing table of R1. R1 routing table. Now R1 is performing load balancing, right, for all two prefixes. Now how I can add some metric here? See, this is the metric, right? From both path it is calculating same metric. Now first of all we need to create access control list as we discussed in last class. First of all we need to define the interesting traffic. We need to classify the traffic. So let's say access control list 10 with permit statement, and network is 2.1. Let's say 0.0. Wildcard mask is 0.0.255.255. Done. And then router EIGRP 123, router EIGRP 123 offset list and access list number 10 direction in, and then let me add what metric? 10. I am going to add metric 10 on which interface? On fast Ethernet 2/0. So once I will hit enter, what it will do? It will add metric 10 with all the prefixes on fast Ethernet 0/0. Router 1 have received, let's say, 1000 prefixes on fast Ethernet 2/0. So it will add 10 metric with 1000 prefixes. See. Now, so IP route EIGRP. Just wait. So IP route EIGRP. Now you can see best path is via which router? Again via router number 3. Why? Because we have add metric 10 on fast Ethernet 0/0. So IP EIGRP topology. In the topology table, how many paths are there? 2. But how many successors are there? Only 1, right? So we have achieved same task with the help of offset list also. Here we have not changed any bandwidth or delay value of interface. Yes or no? Again, my router 3 have installed all path via router number 3 as a best path, and all the prefixes via router number 4 as a backup path. Is it clear? This for this. 2.1.2.0, 2.1.1.0. Got it, guys?
Yes.
Okay, now let me configure last task. See, to configure last task, first of all, we need to remove the previous configuration. Okay, we don't need to remove the previous configuration, but okay, let me remove it. On router number 1, only I have configure access control list and say no access list number 10, and router EIGRP as number 123, and no offset list number 10, no offset list number 10 in, and fast ethernet, which interface 2/0, right? Correct. I have removed it. Now here in this task, in last task, consider R1 and R2 as an edge router, right, connected to ISP, originating a default route from R1 and R2, but all the router like R3, R4, R5 should use the default route of R1 as a primary route, and if R1 failed, then all the routers should use R2 default route. Verify your task configured a loopback on ISP router 8.8.8 as a Google DNS server and see the output. So what it's saying, that let's say router 1 and router 2 are the edge router connected with ISP. On ISP router we have one loopback 8.8.8 is running there, and both router 1 and router 2 are advertising default route to router number 3, 4 and 5. But router 3, router 4 and router 5 should use default route of router number 1 as a primary path. If router 1 is down, then they should use default route of router number 2. So how we will achieve it? See, first of all, let me configure the scenario. Let me check ISP router. So IP interface brief exclude unassign. Yes, we have IP configuration here. We don't need to do anything. Let me close it. On router number 1, I am going to configure one default route. IP route 0.0.0, 0.0.0, and then let's say next hop IP address or exit interface. Next hop IP address is fast ethernet 0/0, and next hop IP address is 100.1.1.2 is the IP. Do ping 100.1.1.2. Yes, ping is working fine, and do ping 8.8.8. Yes, ping is working, right? Here I have configured one default route. On router number 2 also we need to configure one default route. Config T IP default route exit interface was correct. .2 and this said 101.2. okay. Router 2 IP route 0.0.0, 0.0.0, exit interface fast ethernet 0/0, and next hop is 101.1.1.2. Do ping 101.1.1.2. yeah, and do ping 8.8.8. yeah, ping is working fine. Now guys, from both sides see router 3 routing table. So IP route router 3 don't have any default route, right? So router 1 and router 2 have one default route. We are going to advertise that default route in EIGRP domain. Here you can see gateway of last resort is not set, so that I am going to advertise default route of router 1 in EIGRP, so that router 3, 4 and 5 can get that default route. So simply on router number 1 you need to run this command, router EIGRP as number 1 to 3, and default information originate. Default information router EIGRP 100 default information. What is command?
I redistributed the static route inside EIGRP.
Okay.
It's no, it okay.
Default information originate command is not here. Just give me 1 second. Router EIGRP 123, that is fine. Okay, we can do one thing here. Okay, one command is we can say, see, we can say redistribute static. This is the first option. Second option is we can advertise like interface fast ethernet 1/0. Here we can run this command IP summary address for EIGRP 123 or 0.0.0, right? It will advertise default route from this interface. This is the second option. Third option is I think default router EIGRP 123 and IP default network only information. What was the okay, for now let me advertise it with router EIGRP S number 123. There is one more option to advertise with, you know, candidate of default route. I will see the command. What is the command? For now I am going to redistribute static. Okay. On router number 3, now we can verify that router 3 have received default route or not. Yes, router 3 have received one default route from router number 1, but now it is not receiving any default route from router number 2. And let me check router 4. Router 4 should also receive one default route. So IP route EIGRP router 4 is also receiving default route from router number 1, and router number 5 is also receiving one default route. So IP route EIGRP, it is also receiving default route from both neighbor, and it is performing load balancing, right? With actually it is receiving default route with equal FD value from both neighbor, from router number 3 also and from router number 4 also. Fine. Now on router number 2, I am going to advertise default route on router number 2 also in EIGRP domain. This time router number 2 have one default route. So router EIGRP AS number 123 and redistribute static. Fine. Now router number 3 and router number 4, any other router, like on router number 3 you can see, check the routing table. It have received the default route from both neighbor, right? Router 2 is also advertising and router 1 is also advertising, and router 3 is performing load balancing. But what I want that it should use this default route as a primary via router number 1 and as a secondary via router number 2. So how we can achieve that? In the same way, router number 4 also you can see you can verify the routing table now. See, in the routing table there are two default route from both neighbor, from router 1 and router 2, and on router number 5 two default route from both neighbor. So how we can achieve it? See, while redistribution, while we are running this command redistribute static, here we can define what? Metric. We can define metric like k values. So how we can configure k values so that router 2 is advertising default route that should be secondary, and router 1 is advertising a default route that should be primary. So here, let's say I am not defining any metric, then all routers are performing load balancing, and this time here I am going to say bandwidth, you should use bandwidth 1000, or default, this is the default bandwidth of fast Ethernet link, right? 25, this one. And then I'm saying delay should be, let's say 10, and reliability is 255, let's say, and then load is, let's say 100, MTU is 1500 byte. This is configuration of router while redistribution. I have set these components to calculate metric, and on router number 1, when I will redistribute, see, I will change some value. I will set same bandwidth. Here I will say first metric, same bandwidth 245, 244, right? Then delay value here I am going to set 11, 255 and 100 and 1500 byte. Now what will happen? See, on router number 3, this router have installed this default route via which router? Via router number 2. Via router number 2. Okay. Gateway of last resort is 23.1.1.2. What delay I have set here? I've set delay.
We have to give more delay in R2.
More delay on R2, na? So let me say here 12. Right? And now this default route is reachable via which router? Via router number 1. And now we need to check that there is backup secondary default route is available or not. For that I will check topology table. So IP EIGRP topology table. Inside the topology table there should be one more path for default route. Or what we can do here, we can down R1. Let's say no. So IP EIGRP we can note down, and then maybe it will generate query message. How many path? 2 path. And how many successor for this default route? 1 via router number 3. And via router number 4, all the router, let's say router 1 and router, behind router 1 and router 2 there are 100 router. So for all routers, default route is best via router number 1 and backup via router number 2, because while advertising we have set the bandwidth and delay value. Okay, so on router number 5 also you can see now there is, on router number 5 definitely there will be 2 default route, because router 3 and router 4 both are advertising default route of R1, right? But if R1 will goes down, automatically router 5 will install default route via router number 2. Again both neighbor will, router 3 and router 4 will advertise default route of router 2. Okay, so this is default information originate in EIGRP, default route propagation you can say, topic is default information, default route propagation. In default route propagation in EIGRP, we have actually 4 methods. One is redistribute static. Now I am going to remove this command, redistribute static, from router number 1 and from router number 2. Say no to this command, no to this, and on router number 2 also I'm going to say no to this. And now if we will check R3 routing table, so IP route EIGRP, now it is not receiving any default route, right? Now simply second option is on router number 1 and on router number 2, on any router we can run this command, network 0.0.0 command. This command will also advertise default route in EIGRP, network 0.0.0. See, on router number 3, so IP route EIGRP. Again we have, wait, on router number 1 we have run network 0.0.0 command. Yeah, that is correct. Do so IP route so IP EIGRP topology. So it have not installed default route in their topology table. Okay, let me do one thing. I think this command will work with IP route. Let me remove the IP route. Do so run section IP route. I think this command will work when we have a static route with exit interface only. IP route 0.0.0, 0.0.0 and fast Ethernet, let's say 0/0, right? And router EIGRP 123 and network 0.0.0. Let me check again topology table of R1. So IP EIGRP topology. Yes, now you can see it have installed this default route in their topology table, and it will advertise to their neighbor. Like on router number 3, you can see, so IP route EIGRP. Yes, we have one default route, right? Router 1 is advertising it. This is the second option to advertise default route in EIGRP. Third option is, I'm going to remove this command also, router EIGRP S number 123, and say no to this command, network 0.0.0. Again you can see router number, on router number 3 we don't have any default route. Fine. Third option is summarization. As I told you that from this interface we can advertise one summary address. Like, let me show you that also. Interface fast Ethernet 1/0. Here I can run command IP summary address for EIGRP 123 0.0.0 0.0.0. And now on router number 3 you can see we have one default route from router number 1. This is third option to advertise default route in EIGRP. And we have one more option, fourth option. That command actually I am not getting now. Let me remove this one also, and let me try last one. Last option is candidate of default route. In that method, what you can do, with the help of one network you can advertise default route. You can advertise default route. For that you need to create one loopback here with one class full IP address. Let me create one loopback, interface loopback, let's say 11, and IP address is, let's say here I am going to run 192.168.1.1, and 255.255.255.0. Let's say I have created one loopback here only, and now I am going to run this command IP default network 192.168.10.1.1 this. And now let me check router 3 is receiving default route or not. I think router 3 should receive it one default route with this command also, but it is not receiving, right? So there is some, I think I'm missing something in default candidate of default route. I will check the command and I will tell you the last method also. This is the last option to advertise default route that is called candidate of default route. Otherwise, this is the lab only. Now we don't have any task here. Next task is OSPF. Now again guys, I am telling you, you need to configure it by yourself. If you will configure, again you will learn something. Okay, so now if anyone have any question from this lab, in this lab, please ask me. Okay, I think you know why this command is not working. We need to advertise it in EIGRP also. So let me advertise it, router EIGRP as number 123, because router 1 is now not advertising this network, right, to their neighbor. So this command will tell to router that advertise one default network with this network. So let me advertise this network also in EIGRP. Network 192.168.1.1 1.0 1.1, let's say, and 0. Because we are using this loopback only for default information originate. Now on R3, nope, R3 don't have any default route still. Okay. Interface loopback 11, IP address is 192.168.1.1 255.255.255.255. Just give me 1 second. No interface loopback 11. Interface loopback 11 IP address is 192.168.1.1 255.255.255.255. This IP address is completing with this 192.168 router. No IP default network 192.168.1.1 and router EIGRP IP default network 192.168.1.1 and router EIGRP is number 123 network 192.168.1.1 0.0.0. So IP EIGRP topology Okay, and finally let me check R3. No, it is not advertising, right? Default route. Okay, I will check it where I think I am missing one command or there is some concept. Okay, I will check it and I will tell you guys. If anyone have question from today class, please ask me. Otherwise, that's all for today. Now it's your chance. You can configure. You should configure it. If you want to configure, you can configure. You can design the lab in GNS3. And Raja, do one thing. Call me tomorrow morning for GNS3 setup. Okay, brother.
Yeah,
I will set
okay,
up it.
okay, sir.
And tomorrow we will start OSPF routing protocol. And I must tell you guys, OSPF is very important routing protocol. So please try to join all class of OSPF, at least OSPF and BGP. Then we will move to switching module. We have only two left, routing protocol, OSPF and BGP, and both are very important. Okay.